So let's look at how to use your calculator for basic statistics. I like this picture. It's maybe the best pie chart there's ever been because it's an accurate pie chart. Look, it's a pie chart about pie. Pie I've eaten, pie I've not yet eaten is accurate. Okay, so often you're given a list of numbers, and the whole idea is to put them into your calculator, your GDC, your graphical display calculator, and do some sort of statistical analysis. Sometimes this here is known as the 5-number summary. So your calculator will tell you these things, the minimum. So it'll often call it, X min. This is usually the notation it uses. So it might be called X min. First quartile will be called Q1. Median would just be called median. But remember, that's also Q2. We have Q3. We have the maximum, which should be called X max. Now, your calculator also tells you some other things. It turns out it'll tell you the mean. Now, there is a distinction. In SL, we don't really need to know about it. In HL, for sure, it's important, though. But it turns out this right here is the mean for the population. That assumes it's for the entire population. Whereas if we use just a sample, we use X bar right here. That's just saying it's a sample of it. But in the IB, at least for the standard level, we're going to assume that it's for the entire population. That's for the SL, okay? HL, you might be told otherwise, but at least in SL, when we look at the mean, you can see them as interchangeable, even though they're not really. But as far as SL is concerned, we'll kind of use them interchangeably. You'll also be able to find something else. It's called the standard deviation. It has this symbol right here. So this is called standard. We'll have another video, by the way, about it. I'll show you more in detail, especially when we do normal distributions. That's really important. We have this thing called sigma. It looks like this. I think it puts a little x for it, so this is called sigma x. This tells you the spread of the data. So let's take a look at how to do this on your calculator. So here's what you do. I'll show you the idea behind it, and then I've got 2 specific examples. If you use the Casio, it's very similar to this. So the main idea is you got to put everything into your calculator as a list, then you got to do the statistical analysis. Okay, so like put it in, do some math. If you use a TI Inspire, you add a page, you go list in spreadsheets, and you have to name your columns. What I mean by that is that, for example, let me do it maybe in purple here. Let's just say, so I might have like X, and I might have like the frequency. So then I'll have, all my X values here and my frequencies here. Or maybe I've just got X's, so it'll just be X. It'll just be a whole bunch of these like this. That's how I would do it on my TI Inspire. If it's on the 84, you press stats, you go to edit, and you put it in as L1. Frequencies would be L2. So in other words, this right here would be L1. You'd have your big list, and maybe even L2. So you'd have your numbers like this, if you need L2. Now, the idea to do the analysis, well, from the TI Inspire, you just press menu, go to statistics, do some calculations, and you always do one variable, even if you have 2 columns. Because you're still doing it for one variable. The second column is just the frequency. So you actually always just do one variable. Very similarly for the TI-84, you go stat, go to calc, and do one var stats. So you may still need to use a frequency column, but it's not 2 variable stats. It's still, okay, so I'll maybe write this down. It's still 1 variable stats. This is the key thing here, okay? And for the TI Inspire, you really have to name your columns because you're going to have to use them and it won't really know what to call them. So for sure, you got to give them a name. So let me show you what I mean with an example here. So let's say you're doing a test. You're testing a group of people's ability to withstand high G turns. I use this as an example because I've been through this. This is super, super fun. So you go in this big, crazy looking machine here. So you sit on one end of it and it spins you around faster and faster and faster. The idea is to see how well can you, withstand really high G turns. That's because as you spin around, you can simulate, more than one time the force of gravity, or 2 or 3 or whatever. So depending on what kind of G turn you're doing, your body's used to 1G. That's what we feel right now. So 1G feels perfectly normal. Think about this, though. If you're feeling 2Gs, which you might, like on a roller coaster or something like that, or if you're accelerating really fast in a car, like maybe like someone has a Tesla or something like that, they can accelerate quite fast, then you're going to feel a whole bunch of, push on you. This is this idea about high G. I'm not doing a physics class right now because I can be very specific with the terminology, but I'll be a little bit looser with the words right now. But the idea is, if you're feeling 2G, that means, let's say your head weighs, whatever your head weighs. I don't know what the weight of a head is, but that means if you're doing like a high G turn, that means that your head will weigh, if it's 2Gs, that means your head literally weighs twice as much. That means that the blood in your face really wants to go away. So there's these really cool videos you can look up on YouTube. Maybe check them out after you're done with this video here. Look up, centrifuge training, for some videos. You'll see videos of people when they're in this machine. So you'll see they put you in there. It actually doesn't hurt, and you don't feel dizzy. I always thought you'd feel dizzy, but you don't feel the least bit dizzy. They just put you in this. You're really nervous because you want to do well, right? So they put you in this thing, and they just have you spin faster and faster. And those G numbers can go up and up and up, and then you basically just go to sleep. It's called G-lock. It's called G-induced, loss of consciousness. Basically, your peripheral vision just sort of, it's like the sides of your vision just kind of go black and black and black. All of a sudden, everything's black. You've fallen asleep. So what do I mean by fall asleep? I mean, you've passed out. This is your body's way of, putting you to sleep so that you wake up when you're doing better. It's actually really cool that your body does this. So over time, you can have training for it. You can train, to keep awake longer. So there's a weird trick you do. You basically want to make your face really red. So it's kind of weird. You kind of push. And this may sound kind of gross, but it's almost like if you have to poo, but don't poo. But like if you're really pushing, if you can make your face red, that means you're doing it right. So you could you really push and make your face red. That means you're pushing more blood into your brain. That means you're going to stay awake longer. That's the cheating part. So if ever you have to go into one of these machines, do that. There's something else called pressure breathing, which means you have to still breathe once in a while. You basically have to breathe out and breathe in as fast as you possibly can and go back to pushing blood into your brain. Now, what happens is you can also wear a G suit. So that's when you get more advanced. There's actually a suit you can wear. What it does is when it senses that you're accelerating, it actually fills up these bladders of air, and it basically pushes the blood from your calves. It squishes your calves to get the blood up your thighs. It squishes your thighs, and that way, basically the idea is to keep the blood up to your brain where you need it. Anywho, let's actually look at this real thing here. So we've got some times here, how long people stayed awake before passing out. So what's the mean time? What's the average? So let's just go through how to do this on your calculator. So what did I say to do? We go to list and spreadsheet. And I'm going to call it maybe time. I'll actually call it that. Time. Time. So I've named it. All right. Now I'll just put in all my numbers. So I go 8 and 12. I'll just put them all in here. Okay. 9, 8. This is boring to watch me do, I know. I'll go as fast as I can so that you can get out of this boring part here. 10, 14, 7, 5, and 21. There we go, I'm done. So remember I said first step was to put everything into your calculator? Done. Well, in the TI Inspire, at least you press menu, and you say, please give me some statistics, and please do a calculation. I would like one variable statistics, and I only have one list, yes. What is my X list? There, I just like to use the right arrow, so I actually click on the right arrow here, and usually then it gives you a choice, and I'll choose time. Frequencies are all 1, but if you had a list of frequencies, you would then call that, you would have had another column called frequency. But in this case, I didn't, so I just press go. I got everything I need. Now look, I've got the mean, which is 11. Do you see that? So it's 11 seconds. See that? So the mean, the population mean at least, is 11 seconds. Yay. What else do I need? I need the median time. Ooh, what's the median? My calculator tells me that too. Look. And by the way, it tells you the sum of all the x's, the sum of the x squareds. That helps you to calculate things by hand if you want to know some of the middle parts. But the median, let's see here. Oh, look, the median is 9.5 seconds. Okay, whoops. So I got to write that down here. So I'll say, all right, so that's 9.5 seconds. What is the interquartile range? Ooh, I know how to do that. We have an equation for that, don't we, from our formula booklet. IQR equals Q3 minus Q1. Well, I got to look up what's Q3. Q3 is 14. Q1 is 8. So I'll write that down. I'll say 14 minus 8, right? And that is 6. So there we go. That was done. Do you see it's actually really easy? Once you get the stats, super easy. Now, we haven't really taught it or learned it formally, but we can use the standard deviation as well. So we'll use that one. So we could actually say that the standard deviation is, and let's look it up here. And again, there's a distinction between the population one and the sample one, but let's just say we'll just use 4.58. Let's just say 4.58 seconds. So what does this tell you? This tells you that your values here are spread out quite a bit around the mean. So although the average is 9.5 seconds, this tells you, oh, but they're really spread out quite a bit. So that means although, yeah, the average is around 10 seconds, it goes like plus or minus 5, like a lot of the values. So it basically tells you, yeah, the mean might be 9.5, but things are really spread out. That should make sense. Look, you have a 21, you have some lower ones like at 8 or whatever, so and 5 and 8. So there we go. This is how we do this. So I hope this helps and help put this into context.